All right, here we go, guys. This is lesson 11-2, surface areas of prisms and cylinders. It is a pretty lengthy lesson with a lot of information, so I doubt we get this done in one video, but we can always try. Let's start with this picture and all of our vocabulary in the beginning. A prism is a polyhedron with exactly two congruent parallel faces, and those are called bases. You can see that over here on this pentagonal prism, that the shaded green faces are the two congruent parallel bases. These two planes, these two pentagons, would never ever intersect. Thus they are parallel, and they are also congruent. And there are exactly two of them. Then next we have lateral faces. Lateral just means around the sides, so it's the other faces. They're not the bases. So all these other, they're all rectangles. All these other rectangles around the side of the shape, those are all lateral faces. And you see one highlighted blue here. That is one of the lateral faces. An altitude is a perpendicular segment that joins the planes of the bases. So there's an altitude here, this is an altitude, this dashed line back here is an altitude, this is also an altitude, and so is that. So it's those vertical lines that create the edges of your lateral faces, and they connect the bases, and therefore they are altitude. The height is just the length of the altitude. So this could be the height, this would also be the height. Any of these vertical lines could be the height. So if you knew the length of any of these vertical lines, that would be the height of your figure. If you're wanting to find the lateral area, to find the lateral area, you take the sum of the areas of the lateral faces. So you'd have to find the area of each lateral face, of each rectangle, and then add them all together. The surface area is the sum of the lateral area and the area of the two bases. So the surface area is basically the area of each individual polygon, or of each shape on your prism. So your surface area would be the lateral area, all the sum of the areas of all of your lateral faces, in this case rectangles, plus the area of your two bases. And you know your two bases are always the same. They have to be, since it's a prism. All right, let's move on to example 1. We're going to use a net to find the surface area. Oops, let's try that again. To find the surface area of the cube. So the first thing I have to do is draw a net. Okay, if I'm going to draw a net, I know it's going to be made up, since it's a cube, I know it's going to be made up of squares. So here's one. I'll take that one, and I'm going to copy it so I know that it's exact. And we have 1, 2, 3, 3, 4. I don't know why that keeps happening. Okay, and then we also have to have one up here. So those first 4 that I drew, those are all the lateral faces, and then these last 2 that I'm putting on here, these would be my bases. And since it's a cube, all these they're all congruent. So really any 2 could be considered your base, but I would just consider the one on the top and the one on the bottom. I would consider those to be my bases, since that's what they're sitting on. But again, any of them could be your bases, since they're all, you could choose this one and this one to be your bases, the left and the right. You could choose the front and the back, because they're congruent and they're parallel. So any of those 2 congruent parallel sides could be chosen as bases. But again, I'll just choose top and bottom, because when I think of base, I also think of what they're sitting on. We have one piece of information about our cube, and that is that one side is 11 inches. But what's special about a cube? If one side is 11 inches, then every single edge is 11 inches. So I know this is 11 inches, also 11 inches here, 11 inches here. I mean, any edge that you chose, we know would be 11 inches, since it's a cube. So it's special in that regard. Let me get rid of some of that. It looks kind of messy. All we really need to know is, maybe we'll leave these 2 on there, 11 inches and 11 inches. So they've asked us to find the surface area, and we just found out that to find the surface area, we need to take the lateral area and the area of the 2 bases. So I'm going to do 2 times a capital B, and that capital B stands for area of a base. Capital B stands for area of a base. Lowercase b just stands for base. But in this case, capital B stands for the area of the base. So first we need to find the lateral area, and then we're going to add on to that, we're going to add to that 2 times the area of the base. So let me start by trying to find my lateral area. Again, lateral area is just the sum of the areas of all the lateral faces. So let's first, I'm going to highlight all my lateral faces. So that'd be this square, this square, this square, and this square, and those correspond to all these side squares over here. This square, the back, this left side, all those around the sides of the cube, those are my lateral faces. So the lateral area is the sum of the areas of the lateral faces. And all of our faces are squares. All of our faces are squares. So hopefully you remember that to find the area of a square, well, it's just isn't working right now, is it? The area of a square is side squared. Try this again. The area of a square is side squared. There we go. Okay, so I know my side is 11 inches. So if I'm going to find the area of one square, I'm just going to take 11 squared. 11 squared is 121, or 11 inches squared, I should say. So it's 121 inches squared. That's the area of one of our lateral faces. So that means this is 121 inches squared. This square is 121 inches squared. This square has an area of 121 inches squared, and this square has an area of 121 inches squared. So if we're going to find the lateral area, I know that all I have to do is take 4 times the area of one square. Since I have 4 squares, and each of them has an area of 121, then I'll just do 4 times 121, and I end up with 484 inches squared. So my lateral area is 484 inches squared. Now I have to find the area of my 2 bases, and once I do that, I can add those together. So I can take 2 times the area of the base. Okay, so I have, that's equal to 2 times the area of the base. Again, we know these 2 are our bases. These 2 yellow squares here are our bases. And we know they have the exact same area as all of our lateral faces, since that's what's special about a cube. So I know those are both 121 inches squared, so times 121 inches squared. And that means that 2 times the area of the base is 242 inches squared. So I know both parts of my surface area formula, so that now I can find my surface area. So my surface area is the lateral area, 484 inches squared, plus 2 times the area of the base is 242 inches squared. And then when I add those together, I end up with a total of 726 inches squared. There's my surface area. Okay, now you know that you don't have to do it the exact same way I did it. Some of you might want to just throw in all your information right into this formula and work it out like that instead of in pieces. That's totally fine, whatever makes you comfortable. But beyond that, there's even another way to find the lateral area, and we'll see that in just a minute. So keep this in mind, but we will find out another easier way to find our lateral area. So moving on to quick check 1. Here it gets a little more complicated. We just dealt with a cube. That was a pretty simple shape to find the surface area for. So let's get a little more complicated here. They want us to use a net to find the surface area of this triangular prism. So the first thing I need to do then is draw that net. So let me start with drawing my net. And when you draw a net, just imagine opening it up. So I'm imagining folding down these triangular flaps first. And so they would look like, there'd be a triangle there. Then I would take that triangle, then I copy it so I know it's the exact same. Move it down here and turn it around. So I folded down my flaps. Move it down a little bit, it's a little too close. Try and straighten it out here. Okay, and then I'm gonna connect these 2 sides. kind of a perfectionist here. We got to make sure these lines are straight. Of course it's not. Okay, that's close enough. And then we also need to draw these other two rectangles that flank the sides. So let me get those other two rectangles. See, this should be the easiest way here. And I'll resize that in just a minute, or right now. And let me move that down here. Okay, and then I'll just copy this, and let me move it to the other side. Okay,